Day 1. Wood Structures. EMT 1203, Aircraft Wood and Structural Repair. This subject will be covered in Chapter 6 of your FAA 83 textbook. You can also find information concerning structural repairs and defects in your AC 43.131b. Aircraft Wood and Structural Repair. Wood was among the first materials used to construct aircraft. Wood was the material of choice for aircraft construction into the 1930s. Part of the reason was the slow development of strong, lightweight metal aircraft structures and the lack of suitable corrosion-resistant materials for all-metal aircraft. British de Havilland Mosquito Bomber. Wood aircraft construction and repairs. The information presented should not be used in place of the aircraft manufacturer's maintenance manual. When specific manufacturer's manuals and instructions are not available, the Federal Aviation Administration, AC 43.131b, can be used as a reference for inspections and repairs. FAR Part 65 states that a certified mechanic may not perform any work for which he or she is rated unless he or she has performed the work concerned at an earlier date. This means that if a mechanic does not have the previous aviation woodworking experience performing the repair, he or she should be supervised by a mechanic that has previous experience in that area. Inspection of wood structures. To properly inspect an aircraft with wooden structures, the aircraft must be dry. It should be placed in a dry, well-ventilated hangar with all inspection panels and covers removed. This allows the interior to thoroughly dry. If there is any question that the wood is dry, a moisture meter is used to verify the percentage of moisture in the structure. The ideal range is between 8 and 12%, with any reading over 20% providing an environment for the growth of fungus in the wood. 663, 8083. External and internal inspection. The inspection should begin with an examination of the external surface of the aircraft. This provides a general assessment of the overall condition of the wood and structure. The wings, fuselage, and empennage should be inspected for undulation, warping, or any other disparity from the original shape. During internal inspection, if a musty or moldy odor is apparent as you remove the access panels, this is a good indication of moisture, fungal growth, and possible decay. 6. 38083. Glue joint inspection. The inspection of glue joints can be very difficult to inspect. Keep this in mind when inspecting any glue joint. Some common factors in premature glue deterioration include chemical reactions of the glue caused by aging or moisture, extreme temperatures, or a combination of these factors, and mechanical forces caused mainly by wood shrinkage and development of fungal growth. An aircraft painted in darker colors experiences higher skin temperatures and heat buildup within its structure. Perform a more detailed inspection on a wooden structure immediately beneath the upper surface for signs of deteriorating adhesives. Glue joint inspection continued. In cases of glue joint failure, whatever the direction of loading, there should be a fine layer of wood fibers adhering to the glue. The presence of fibers usually indicate that the joint itself is not at fault. Examination of the glue under magnification that does not reveal any wood fibers, but shows an imprint of the wood grain, indicates that the cause of the failure was the pre-drying of the glue before applying pressure during the manufacture of the joint. 64. 88. Purchasing aircraft wood. There is a difference between how lumber and aircraft wood are cut at the sawmill. Figure 6-7-2 shows it better than it can be explained. flat sawn lumber, this produces the most lumber in the widest boards possible from a log. This is what you get when purchasing lumber from Lowe's or your local home supply store. It also shrinks, warps, splits, and crawls all over the place. Quarter sawn lumber, this produces a better quality piece of lumber that does not exhibit any of the undesirable qualities of flat sawn lumber. The process is somewhat wasteful and time-consuming. 6101 Avotech Wood condition. Wood decay and dry rot are usually easy to detect. Decay may be evident as either a discoloration or a softening of the wood. Dark discolorations of the wood or gray stains running along the grain are indicative of water penetration. In some instances where water penetration is suspected, a few screws removed from the area in question reveal, by their degree of corrosion, the condition of the surrounding. Joint 65883. Wood condition. Wooden aircraft are more prone to the damaging effects of water, especially without the protection of covered storage. Control system openings, fastener holes, cracks or breaks in the finish, and the interfaces of metal fittings and the wood structure are points that require additional attention during an inspection. Inspect structural members for compression failures, which are indicated by rupture across the wood fibers. This is a serious defect that can be difficult to detect. If a compression failure is suspected, a flashlight beam shown along the member and running parallel to the grain will assist in revealing it. 658. Repair of wood. Aircraft structures. Materials. All repairs of wooden aircraft structures should be accomplished in accordance with the manufacturer's specifications and/or instruction or other approved data. Several forms of wood are commonly used in aircraft. Solid wood refers to a member consisting of one piece of wood. Laminated wood is an assembly of two or more layers of wood that have been glued together with the grain of all layers, or laminations approximately parallel. Plywood assembled product of wood and glue that is usually made of an odd number of thin plies or veneers, with the grain of each layer placed 90 degrees with the adjacent ply. High-density material includes compreg, impreg, or similar commercially made products, heat-stabilized wood, or any of the hardwood plywoods. Commonly used as bearing or reinforcement plates. 678. Wood propeller fabrication. Suitable wood. The various species of wood listed in Figure 6.10 are acceptable for structural purposes when used for the repair of aircraft. Spruce is the preferred choice and the standard by which the other wood is measured. Information on suitable wood is also found in AC 43.13-1P-1. The one item common to all the species is that the slope of the grain cannot be steeper than a 115. For certified aircraft, the wood should have traceability to a source that can provide certification to a military specification, aircraft grade, or aircraft quality. To purchase the material, contact one of the specialty aircraft supply companies and request a certification document with the order. At the completion or the repair, as always, it is the responsibility, if the person returning the aircraft to service, to determine the quality of the replacement wood and the airworthiness of the subsequent repair. 6768. Defects permitted, not permitted. The defects that can or cannot be permitted are listed under the notes for Table 1 1 in AC 43.18b. Any defects found should be inspected and assessed for airworthiness. 69888 and 3. Glues, adhesives. Because adhesives play a critical role in the bonding of aircraft structures, the mechanic must employ only those types of adhesives that meet all of the performance requirements necessary for use in certified aircraft. Your AC 43.131b provides information on the criteria for identifying adhesives that are acceptable to the FAA. Refer to the maintenance manual for instructions on acceptable adhesive selection. Adhesives meeting the requirement of a mil-spec AMS or TSO for wooden aircraft. Structures are satisfactory, providing they are compatible with existing materials and fabrication methods. 6 to 10, 8083. Glues, adhesives continue. Some of the more common adhesives that have been used in aircraft construction and repair include Kazan glue, plastic resin, resorcinol, and epoxy adhesives. Kazan glue should be considered obsolete for all aircraft repairs. It deteriorates when exposed to moisture and is a milk-based product that supports fungus growth. All traces should be removed before a new adhesive is applied. Plastic resin glue or urea formaldehyde glue should be considered obsolete for all aircraft repairs. Resorcinol glue or resorcinol formaldehyde glue meets all strength and durability requirements if the fit of the joint and the proper clamping pressure results in a very thin and uniform bond line. Epoxy adhesive is a two-part synthetic resin product. Many epoxies have exhibited joint durability in the presence of moisture and elevated temperatures and are not recommended for structural aircraft bonding unless they meet the acceptable standards found in AC 43.13 Bit 1b. Note: all manufacturers' product data sheets must be followed regarding mixing usable temperature range and the open-closed assembly times. 6 and 8, 83.3. Terms used in the glue process: close contact adhesive, gap filling adhesive, glue nut, single spread, double spread, open assembly time, closed assembly time, pressing or clamping time, adhesive put life. 611, 8083. Preparation of wood for gluing. Satisfactory glue joints in aircraft should develop the full strength of the wood under all conditions of stress. Some conditions required to obtain this full strength are proper and equal moisture content of wood to be joined, 8 to 12%, properly prepared wood surface that are machined or planed and not sanded or sawed, selection of the proper adhesive for the intended task, which is properly prepared and of good quality, the application of good gluing techniques including fitment, recommended assembly times, and adequate equal pressure applied to the joint, performing the gluing operation under the recommended temperature conditions. Note: it is advisable to clean all surfaces with a vacuum cleaner prior to adhesive application. Never glue on a sanded joint for solid wood. Preparing glues for use. The manufacturer's directions should be followed for the preparation of any glue or adhesive. Whatever method is being used, the glue should be thoroughly mixed and free from air bubbles, foam, and lumps of insoluble. Applying the glue adhesive. To make a satisfactory bonded joint, it is generally desirable to apply adhesive to both surfaces and join in a thin, even layer. The adhesive can be applied with a brush, glue spreader, or a grooved rubber roller, or following the adhesive manufacturer's application instructions for satisfactory results. Pressure on the joint. When applying pressure to a glued joint, the pressure should be even. Using non-uniform pressure will result in a weak bond. Pressure may be applied by means of clamps, elastic straps, weight, backing bag, or other mechanical devices. The full curing time of the adhesive is dependent on the ambient temperature. Therefore, it is very important to follow the manufacturer's product data sheets for all phases of the gluing operation. All gluing operations should be performed above 70 degrees for proper performance of the adhesive. Repair of wood aircraft components. Ribs that have sustained damage may be repaired or replaced depending upon the type of damage and location in the aircraft. If new parts are available from the aircraft manufacturer or the holder of a PMA for the part, it is advisable to replace the part rather than to repair it. Plywood skin repairs. Fabric patch, spline patch, surface patch, plug patch, scarf patch, wood aircraft construction. Day 2. Fabric covering, Fulcrum airframe, wood structures and acceptable wood, and wood substitutes, wood decay inspection, defects and repairs of wood. Aircraft fabric covering, aircraft fabric covering general history. Finely woven organic fabrics, such as Irish linen and cotton, were the original fabrics used for covering airframes, but their tendency to sag left the aircraft's structure exposed to the elements. To counter this problem, builders began coating the fabric with oils and varnishes. In 1916, a mixture of cellulose dissolved in nitrate acid, called nitrate dope, came into use as an aircraft fabric coating. This coating protected, adhered, and taunted the fabric. The major drawback to nitrate dope was its extreme flammability. Then came the introduction of cellulose dissolved in butyric acid, called butyrate dope. This product did protect the fabric, but had poor adhesion qualities. Aircraft covering general history. With the mixture of nitrate and butyrate dope, this protected the fabric from dirt and moisture, but did nothing to protect the fabric from ultraviolet radiation, UV, which passes through the dope and destroys the fabric. Eventually, aluminum solids were added to the butyrate coatings. With this mixture, the fabric was now protected from the effects of UV rays. Regardless of the treatments, organic fabrics have a life-limited lifespan of only 5 to 10 years. It was not until the introduction of polyester fabric as an aircraft covering in the 1950s that the problem of the limited lifespan of fabric covering was solved. 3.2.88.3. Fabric terms. Warp, the direction along the length of the fabric. Fill, woof, weft, weave, the direction across the width of the fabric. Count the number of threads per inch in warp or filling. Ply, the number of yarns making up a thread. Bias, a cut or fold or seam made diagonally to the warp or fill threads. Pinked, edge, an edge which has been cut by a machine or a pair of pinking shears, giving you a serrated edge. Selvage edge, the edge of cloth, tape, or wedding woven to prevent raveling. Grage condition of polyester fabric upon completion of the process before being heat shrunk. Cross-coat brushing or spraying, where the second coat is applied at a 90 degree to the direction the first coat was applied. PS 3.3. PMERA 1280-83. Legal aspect of fabric covering. When a fabric-covered aircraft is certificated, the aircraft manufacturer uses materials and techniques to cover the aircraft that are approved under the type certificate issued for that aircraft. The same materials and techniques must be used by maintenance personnel when replacing the aircraft fabric. Descriptions of these materials and techniques are in the manufacturer's service manual. Legal aspect of fabric covering. But what if you want to recover the aircraft with a material that was not originally certified with the aircraft? There are 3 ways to gain FAA approval to recover an aircraft with materials and process other than those with which it was originally certified. The first type is by the use of a STATIC. The STC must specify that it is for the particular aircraft model in question. It states in detail exactly what alternate materials must be used and what procedures must be followed. Deviation from this STC data in any way renders the aircraft unairworthy. The second way to gain approval to recover an aircraft with different materials and processes is with a field approval. A field approval is a one-time approval issued by the FAA, FSDO, for that specific aircraft make, model, and serial number. The third way is for a manufacturer to secure a pre-approval through the type certificate data sheet for a new process. Legal aspects of fabric covering. Fabric recovering is considered a major repair or alteration, and FAA Form 337 is executed whenever an aircraft is recovered with fabric. This means that replacing cotton fabric with polyester fabric is a major alteration. A properly executed FAA Form 337 also needs to be approved in order for this alteration to be legal. Be sure that your local IA is available during this process to help out and to approve the 337 and aircraft for return to service. Approved materials. In order for the items to legally be used, the FAA must approve the fabric, tapes, threads, cords, glues, dopes, sealants, coatings, thinners, additives, fungicides, rejuvenators, and paints for the manufacturer, the holder of an STC, or a field approval. Fabric. A technical standard is a minimum performance standard issued by the FAA for special materials, parts, processes, and appliances used on civil aircraft. When a company is approved to manufacture or sell an approved aviation fabric, it applies for and receives a Parts Manufacturing Approval, PMA. Currently, only a few approved fabrics are used for aircraft coverings, such as the polyester fabrics Sanconite, Stitz Polyfiber, and Superflight. These fabrics and some of their characteristics are shown in Figure 3, Poly 3, 4.3. Other fabric covering materials. Anti-chafe tape used on sharp protrusions, ribs caps, metal seams, and other areas to provide a smother surface to keep the fabric from being torn. Reinforcing tape used on rib caps after the fabric covering is installed to protect and strengthen the area for attaching the fabric to the ribs. Rib bracing applied span-wise and alternately wrapped around a top rib cap and then a bottom rib cap, progressing from rib to rib until all are braced. Surface tape made of polyester material and often pre-shrunk is obtained from the STC holder, used over seams, ribs, patches, and edges. It can come in either pinked edge or straight. Pinked edge increases surface area for increased adhesion. Rib lacing. Cord used to lace the fabric to the wing ribs is available in a round or flat cross-section. Sewing thread used in the creation of pre-fitted envelopes for hand sewing thread It's a 3-ply uncoated polyester thread with a 15-pound tensile strength. Machine thread is typically 4-ply polyester with a 10-pound tensile strength. 680 special fabric fasteners. If at all possible, the original manufacturer's methods of fastening should be used. Use of unapproved fasteners can render the covering job unairworthy if substituted. All fasteners and rib lacing are covered with finishing tape once installed to provide a smooth finish and airflow. Grommets. Grommets are used to create reinforced drain holes in the aircraft fabric, usually made of aluminum or plastic. They can be glues in or doped in place. Never use a soldering iron to create the hole on plastic grommets. 3 to 6, 8083. Inspection rings. The structure underneath an aircraft covering must be inspected periodically. To facilitate this in fabric-covered aircraft, inspection rings are glued or doped to the fabric. They provide a stable rim around an area of fabric that can be cut to allow viewing of the structure underneath. 36, 80,883. Primer. In a fabric recovering process, the final preparation procedure involves priming the structure with a treatment that works with the adhesive and first coat of fabric sealant that are to be utilized. Each STC specifies which primer or, if a wood structure, which varnishes are suitable. Utilize the primer specified by the manufacturer's or STC's instructions. 3. 8083. Fabric cement. Modern fabric covering systems utilize special fabric cement to attach the fabric to the airframe. Be sure to utilize a cement that is compatible with the primer and fabric sealer. 3. 7. 8083. Fabric sealer. This surrounds the fibers in the fabric with a protective coating to provide adhesion and keep out dirt and moisture. The sealer is the first coat applied to the polyester fabric after it is attached to the airframe and heat shrunk to fit snugly. 3. 8. 8083. Fillers. The filler contains solids or chemicals that are included to block UV light from reaching the fabric. Proper fill coating is critical because UV light is the single most destructive element that causes polyester fabric to deteriorate. 3. Top coats. Once the aircraft fabric has been installed, sealed, and fill coat protected, finishing or top coats are applied to give the aircraft its final appearance. There are colored butyrate dope product available, but the more common top coat these days will be the polyurethane top coat. It is important to use the top coat products and procedures specified in the applicable STC to complete an airworthy fabric recovering job. The following is a short list of additional products that facilitate the proper application of the fabric coatings. Note again that only products approved under a particular STC can be used. Top coats continued. Catalyst accelerates a chemical reaction, commonly used with epoxies and polyurethanes. Thinner is a solvent or mixture of solvents added to a product to give it the proper consistency for application. Retarder added to S product to slow drying time can be used to prevent blushing of a doped finish when high humidity conditions exist. Accelerator contains solvents that speed up the drying time of the product with which it is mixed. Rejuvenator used on dope finished only contains solvents that soften coatings and allow them to flow slightly. also contains fresh plasters that increase the flexibility and life of the coating. Fungicide important for organic fabric-covered aircraft like cotton and linen. Modern coatings formulas contain pre-mixed antifungal agents. Available covering processes. The aircraft fabric covering process is a three-step process. First, elect an approved fabric. Second, follow the applicable STC steps to attach the fabric to the airframe and to protect it from the elements. Third, apply the approved top coat to give the aircraft its color scheme and final appearance. In the rare instance, the technician encounters a cotton fabric-covered aircraft that is still airworthy, inspection and repair procedures specified in AC 43.13 Chapter 2 Fabric Covering should be followed. Aircraft fabric covering process in time lapse. Determining fabric condition repair or recover. Recovering an aircraft with fabric is a major repair and should only be undertaken when necessary. Often a repair to the present fabric is sufficient to keep the aircraft airworthy. The original manufacturer's recommendations or the covering process STC should be consulted for the type of repair required for the damage incurred by the fabric covering. Fabric strength. How fabric breaking strength is determined. The strength of fabric must be determined at every 100 hours and annual inspection. Fabric is considered airworthy until it becomes 30% deficient in strength. When testing the breaking strength of fabric, one should consult the manufacturer's maintenance manual first for fabric strength inspection methods. Fabric testing device is one type of fabric tester, is the Mahl tester. It is pressed squarely against the fabric until the scale reads the amount of maximum allowable degradation. If the tester does not pass through the fabric, then it can be considered airworthy, but if it passes through, it should be followed with further testing. The second type of tester is the Saboth. It's not as popular as the Mahl tester because it will puncture the fabric regardless if the fabric passes or fails. If your tests result in a failure, you should follow the test by a FAA-approved pull test. A 1/4x4x6 strip of fabric is removed from the area that had failed and sent for testing. Note: the Mahl and Saboth testers are not FAA approved. Fulcrum, airframe, aircraft covering and techniques.